In the last lecture segment, I talked about infrastructure and how it represents the compute, storage, networking, and applications components that are required to deliver a service within our organization. Well, when we talk about infrastructure in the context of cloud computing, generally we're talking about distributed infrastructure. And this is basically a computing architecture where the software services are running on multiple distributed components. For example, you might have a software application that is running on dozens or even hundreds of different web servers. You may have data which is partitioned and distributed across multiple database servers. You have load balancers, which are taking in incoming requests and redirecting or distributing those requests to our fleet of web servers. And all of this infrastructure is designed to allow us to scale our application services to support thousands or even millions of customers. When we created our applications in traditional IT, we would take a monolithic application and install it on a physical server. And then over time, as the demands on that server grew, we would replace the server with a larger system. This is what we call scaling up the system. It's the scale-up model. If I need to support more customers or more users, I just simply buy a bigger system with more CPU and more memory and faster hard drives. Today, with modern distributed applications, I'm not installing my application on a single server. I'm installing my application on a fleet of servers. And when I need to increase the performance or the scalability of my service, if I need to support more customers, then I just simply go out and buy more servers. And this is what we call a scale out model. So instead of buying a bigger server, I'm just buying more servers. Well, this scale out architecture has created some real challenges for us when it comes to architecting our software applications. In a traditional world, we would have a single instance of our application running on a single server. And that was pretty easy to deal with. But in a distributed architecture, I now have multiple instances of my application running across multiple servers. And because we're potentially handling and supporting a larger base of users and customers, we need a way to be able to distribute requests that are coming to our platform to application components that are best suited to handle those requests. The application or the application state or data isn't going to be just stored on one application server. It's going to be generally stored separate from the application servers. And so we need a way to partition and access that data efficiently. And we have challenges when it comes to deploying updates to our application platform, because traditionally we might just be simply updating one application running on one server, and that was fairly straightforward. But how do you update hundreds or even thousands of instances of your application? You likely can't update them all at once, meaning that you need to support a scenario where you have multiple versions of your application running in the distributed architecture concurrently. And finally, in a world where you're supporting thousands or millions of customers, you won't have the opportunity to shut down your service for maintenance. Your service needs to be able to run 24/7, and it has to be designed to automatically handle failures. Our traditional applications were generally designed in a monolithic fashion. Well, what does that mean? Well, it could mean that all of the code of our application existed in a single service or a single file that we execute. Or it could mean that our application is sort of partitioned into different layers, where I have a one layer that's supporting the user interface, one layer that's supporting maybe the business logic, and a third layer that is supporting data. And this is commonly referred to as a 3-tier architecture. But even in that sort of situation, my application is still mainly monolithic, because if I want to update the business rules of my application, then I need to update the one entire layer. I have to essentially update all of my services in order to just update one. With a microservices architecture, which is a more modern architecture, which really aligns well with distributed architecture in the cloud, a microservices architecture is one where each service exists as its own lightweight application, as its own separate decoupled application. And the development teams have the ability to work on each service individually, update and make changes to these services individually, and deploy them into the distributed architecture individually. This, of course, has created a number of new challenges as well, because as you can imagine, working with just sort of one single code base is sort of fairly straightforward, because if you're going to be making changes to the application, then there's just sort of one code base that you're dealing with. But if you're dealing with really a set of applications where in a microservices architecture, you might have dozens or even hundreds of different services that are coordinating with one another, then that introduces a significant amount of complexity in terms of trying to support a cohesive platform using multitudes of smaller individual components.